Hi, my name is Alex Ayala, and this is my intern project partner.
Hi, my name is Yevgeny Surovsky. I go by Gene in class. This is our EE106 Mechatronics final project. Professor is Dr. Furman. So what we did was implement a solar tracking algorithm with a solar panel and a few servos. In terms of distribution of labor, what we initially did was all planning together. So we sat down, we had a meeting after we got advice from Dr. Furman about our project and how to implement it. We divided it into two elements, the hardware and software. But prior to actually spreading off and accomplishing those tasks individually, we planned all the overview and overhead logic. So that means we realized exactly what components we'd be needing, and we came up with a preliminary pin assignment that he'd be able to use in the code and I'd be able to make on the shield. Beyond that, we also came up with the code flowchart, basically going over the algorithm and the logic and determining exactly what we want our circuit to do and when we would want it to do it. At that point, we did split off into kind of work on the separate components that we discussed previously. I was in charge of hardware, so that included making the Arduino shield, as well as getting the base cut out and put together. On top of that, I made the wiring harness, the clamp for the servo to actually mount the solar plate, which you'll be able to see here. I also soldered 3 switches that we'd be able to use for demonstration purposes. So each one of those switches would represent a city at a time that we assigned that we'd be able to use for the demo.
So I was working on the software, and initially we were going to use our approach of light-dependent resistors, and if one of those light-dependent resistors had more luminosity on it than the other, then these servos would move to the one that has more. But although that's a conventional way to do it, the sensors could malfunction or it could be cloudy, so it's not exactly reliable. So Dr. Furman showed us and inspired us to actually look online to find complex equations and calculations to turn your terrestrial coordinates, where you are on the face of the Earth, with celestial coordinates, the Earth orbiting around the Sun, which gives you the time of year, and based on the Earth's rotation about its axis gives us a declination. And from all that information, a few other complex constants and equations, we were able to determine the solar azimuth and zenith angles, and from those that gives us a direct representation of the Sun's position in the sky. The azimuth angle is referenced from north, and this was more useful because our servos, instead of deciding to turn to one light-dependent resistor or the other, they can predict and move in real time, so they're optimally facing perpendicular to the Sun, so the solar panel can constantly be getting max input from the Sun's rays.
Yeah, having said that, this was a great project. We got to learn a lot. As EEs, we don't often have to work with power appropriation to motors and servos. That was a great thing to learn, sizing out the motors, making sure they can actually handle the weight of the panel and be able to have enough power to actually draw, and actually circle the panel around. Having said that, we want to thank Dr. Furman for inspiring us to approach this project from a different angle. I know I personally learned a lot in terms of, the benefits of having different approaches to conventional projects. We also learned that even though the calculations on the Arduino actually do take a little bit more power than reading the photoresistor, on a cloudy day or on a day that the sensors are malfunctioning, it saves the system a lot of power. The reason for that is, again, if it's a cloudy day, you're going to be wasting a lot of power turning the solar cell around, trying to always optimize it, versus ours, we know exactly where to point it. So we send a little bit of power to the servos, we point it exactly where we want to go, and the system's pretty much set until we tell it to move again. So again, thank you, Dr. Furman. Looking forward to taking your final.
Thank you.